Beneath the sun-dappled surface of tropical coral reefs, or drifting silently in the deep twilight of the open ocean, the octopus exists as an enigma, both alien and intimately familiar. Its body, soft and boneless, flows like liquid as it glides across the seabed, 8 arms undulating with a grace that appears almost deliberate, almost human. Yet this is not a creature guided solely by instinct. The octopus demonstrates a level of intelligence, dexterity, and environmental awareness that challenges conventional notions of invertebrate behavior. The evolutionary story of the octopus begins over 300 million years ago, tracing back to mollusks that first ventured into marine habitats with soft bodies and protective shells. Over time, selective pressures favored flexibility, concealment, and rapid adaptation. The ancestral octopus shed its external shell, a trade-off that increased vulnerability but provided unmatched mobility, dexterity, and opportunity for behavioral complexity. This decision in evolution reshaped the cephalopod lineage, giving rise to an organism capable of extraordinary feats, squeezing through narrow crevices, manipulating objects, and executing elaborate escape strategies. Anatomically, the octopus is a marvel. Its 8 arms, each lined with hundreds of suction cups, operate with remarkable independence. Neural control in the octopus is decentralized. Nearly 2/3 of its neurons reside in the arms themselves, allowing them to react and manipulate objects without direct input from the central brain. This enables a single arm to open a shell, probe a crevice, or grasp a prey item while other arms continue exploring the surroundings or propelling the animal forward. Beneath the skin lies another form of intelligence: chromatophores, iridophores, and leucophores. These specialized cells allow the octopus to shift color, pattern, and even texture with astonishing speed. A mottled brown pattern may mimic a rock, a bright flash of color may startle a predator, or complex patterns may signal intent to another octopus. Unlike simple camouflage, octopus color change is highly dynamic, often coordinated with body posture, movement, and environmental cues, making the animal appear as a living chameleon of the ocean. Feeding behavior is equally impressive. Octopuses are carnivorous predators, specializing in crustaceans, mollusks, and fish. Their hunting methods combine stealth, intelligence, and physical prowess. Some species utilize jet propulsion to ambush prey, while others employ a patient, creeping approach, probing under rocks with their arms to detect hidden animals. When necessary, they inject venom through their beak-like jaws, immobilizing prey with a paralytic cocktail of neurotoxins. Observation of octopus intelligence has revealed behaviors once considered uniquely mammalian. Certain species have been documented using coconut shells or discarded shells as mobile shelters, carrying them across the seabed for protection, a sophisticated example of tool use rarely seen outside primates. In experimental settings, octopuses have demonstrated the ability to navigate mazes, solve complex puzzles, and remember solutions over time, indicating both short-term and long-term memory capabilities. The nervous system and sensory apparatus of the octopus also contribute to its exceptional abilities. Its eyes are highly developed, capable of detecting polarized light and discerning subtle changes in the environment. While color vision remains limited, the ability to perceive contrast and motion allows octopuses to detect approaching predators and prey with extraordinary efficiency. Meanwhile, the tactile sensitivity of the arms ensures that even blind exploration can result in successful foraging. Within its marine environment, the octopus occupies a critical ecological niche. By preying on crustaceans, fish, and mollusks, octopuses help regulate populations and maintain balanced ecosystems. They also serve as prey for larger predators, including sharks, moray eels, dolphins, and seabirds, integrating themselves into the intricate web of marine life. The reproductive cycle adds another layer of complexity and tragedy to their story. Most octopus species reproduce once before death, a semilparous strategy. Females carefully lay eggs in hidden crevices or dens, guarding and tending them with meticulous attention. During this period, the female may forego feeding, dedicating her energy entirely to the protection and aeration of the eggs. Once the hatchlings emerge, the female generally dies, completing a life cycle that balances intelligence, reproductive investment, and mortality. From the perspective of humans, octopuses have long inspired fascination and reverence. Ancient cultures depicted them in art and mythology as symbols of mystery, fluidity, and adaptability. Today, they remain objects of scientific curiosity and public wonder, emblematic of the intelligence, adaptability, and resilience of marine life. The octopus demonstrates that intelligence and ingenuity are not confined to animals with bones, fur, or feathers. Within a soft-bodied, 8-armed creature lies the capacity to observe, learn, plan, and manipulate, a testament to the diverse possibilities life can explore across the planet's oceans. In the silent reefs, the shadowed abyssal plains, and the undulating seagrass meadows, octopuses continue their nightly work, exploring, hunting, building dens, and interacting with their environment. Each movement, each color change, each carefully planned maneuver is a thread in the intricate tapestry of oceanic life, a tapestry shaped by millions of years of evolution and by the unyielding intelligence of one of the sea's most fascinating inhabitants. As twilight fades into the inky darkness of deeper waters, octopuses become masters of the unseen, their movements nearly ghost-like against the shifting blue of the ocean. Each arm operates almost as an independent entity, probing, tasting, and feeling the environment with a sophistication that seems almost deliberate, like a musician improvising on multiple instruments simultaneously. The suction cups lining each arm are not mere grasping devices, they are endowed with chemoreceptors and mechanoreceptors, allowing the octopus to taste surfaces, detect chemical signals, and sense vibrations in the water. This multi-sensory toolkit allows an octopus to explore and manipulate objects with astounding precision, whether opening a clam, prying loose a crab from its shell, or navigating through the labyrinth of coral. Camouflage is not merely for hunting but for survival itself. When threatened, an octopus can instantly alter its color, pattern, and texture to mimic surrounding rocks, corals, sand, or even the shadows of drifting seaweed. Some species, such as the mimic octopus, take this capability to a new level, contorting their bodies and positioning their arms to resemble other creatures, lionfish, flatfish, even sea snakes, thus warding off potential predators. This dynamic adaptation is controlled by a complex interplay of neural networks and chromatophores, allowing split-second adjustments that are both reactive and anticipatory, tuned perfectly to environmental cues. The hunting strategies of octopuses are similarly adaptive. Unlike web-building predators or those that chase prey over long distances, octopuses employ a combination of stealth, problem-solving, and opportunism. They may stalk prey slowly, using camouflage to approach without detection, then strike with lightning speed. In some cases, they employ trap hunting techniques, blocking the exits of crab burrows with their arms or coaxing prey into confined spaces to immobilize them. Each encounter demonstrates not only physical skill but also cognitive complexity. Researchers have documented octopuses remembering solutions to puzzles days later and even learning by observation rare behaviors among invertebrates. Their bodies themselves are instruments of innovation. Without bones to limit flexibility, octopuses squeeze through cracks and crevices no larger than a coin, a skill that allows escape from predators and access to hidden food sources. This elasticity also enhances their capacity for rapid movement, whether jetting away from danger or gliding with subtle undulations to conserve energy. Coupled with a siphon that expels water with precise control, octopuses achieve remarkable propulsion, capable of both bursts of speed and near-silent drift. Despite these advantages, octopuses face numerous threats. Sharks, eels, dolphins, and seabirds all actively hunt them, while even smaller predators exploit moments of vulnerability. Some octopuses fall victim to parasitic organisms or infections that can compromise their health. Yet their intelligence provides a counterbalance. Clever escape tactics, misdirection, and environmental manipulation increase survival odds significantly. For example, some octopuses will carry coconut shells or discarded shells as portable shelters, assembling them into fortified dens on the ocean floor, an extraordinary display of tool use rarely seen outside mammals. The reproductive habits of octopuses add further complexity to their story. Most species are semilparous, reproducing once before dying. Males, often smaller than females, must carefully navigate courtship, using precise patterns of arm movements and color changes to signal their identity without being mistaken for prey. Females, after mating, focus intensely on egg care, guarding and aerating their clutch of hundreds or thousands of eggs, often for weeks or months, depending on the species and temperature. During this period, females rarely feed, sacrificing their own survival to ensure the next generation. Once hatchlings emerge, the mother typically dies, completing a life cycle that intertwines intelligence, strategy, and mortality. Ecologically, octopuses play a significant role. They regulate populations of crustaceans, mollusks, and fish, maintaining balance in reef and benthic communities. The dens, often abandoned or remodeled over time, provide shelter for numerous other marine species. In some ecosystems, the presence of octopuses can influence the distribution and behavior of prey species, shaping entire communities through predation and environmental modification. Human fascination with octopuses continues to grow. From the myths and folklore of coastal cultures to modern studies in neurobiology and robotics, octopuses inspire awe. The decentralized nervous systems, rapid problem-solving, and capacity for learning have become subjects of research in artificial intelligence, biomechanics, and materials science. Silken suckers, arms and chromatophores all provide lessons about adaptability, precision, and efficiency. Engineers model soft robotics after the flexibility of octopus arms, while neuroscientists study how distributed intelligence enables complex behavior without a centralized brain. Despite their intelligence, octopuses are sensitive to environmental change. Climate shifts, ocean acidification, overfishing, and habitat destruction affect prey availability, denning sites, and reproductive success. Preserving diverse marine habitats is essential not only for octopuses themselves but also for the countless organisms that rely on the balance these predators help maintain. In the stillness of the deep ocean, octopuses continue to move, hunt, and interact with their surroundings with a level of sophistication that belies their invertebrate classification. Each color change, each carefully calculated movement, each intricate manipulation of objects reflects a remarkable evolutionary solution: survival through intelligence, adaptability, and mastery of a fluid, unpredictable world. Beyond the individual life of an octopus lies a narrative of interaction and adaptation that unfolds across generations and ecosystems. While solitary by nature, these creatures exist within a network of environmental pressures, predator-prey dynamics, and seasonal rhythms that dictate behavior and survival strategies. The subtle interplay between instinct and learning shapes not only how octopuses hunt or evade predators but also how they navigate complex physical and social environments. Juvenile octopuses, after hatching from eggs hidden deep within crevices or dens, face immediate challenges. Vulnerable to predation, starvation, and environmental hazards, they must quickly develop the skills necessary to survive. Many species engage in a form of dispersal called planktonic drifting, where tiny hatchlings are carried by currents across reefs, seagrass meadows, or open waters. This dispersal reduces sibling competition, spreads populations across suitable habitats, and exposes juveniles to diverse environmental conditions that accelerate learning and adaptation. As they grow, octopuses engage in increasingly complex behaviors. Tool use is among the most compelling evidence of their intelligence. Some species collect coconut shells, seashells, or other debris and use them as shelters or protective barricades. In certain cases, octopuses carry these items across the seafloor, assembling defensive structures that can be reused over days or weeks. This behavior demonstrates foresight, spatial reasoning, and an understanding of cause and effect relationships, a cognitive sophistication rare among invertebrates. Hunting strategies continue to evolve with experience. Octopuses are primarily ambush predators, relying on stealth and rapid bursts of movement. They approach prey with precision, often observing and calculating before striking. In reef environments, octopuses exploit complex terrain, using crevices, corals, and rocks to conceal their approach. They may even manipulate objects, such as rocks or shells, to flush prey or block escape routes. The coordination of multiple arms, sensory input, and fine motor control reflects both anatomical specialization and cognitive ability. Camouflage remains central to survival. Beyond simple color matching, octopuses alter texture, pattern, and posture simultaneously. They may flatten their bodies to resemble a rock, extend arms to mimic seaweed, or produce bold patterns to intimidate predators. This dynamic camouflage is not purely reactive. Octopuses can anticipate threats and select appropriate strategies, demonstrating flexible, context-dependent behavior. Some species also use mimicry as deception, imitating venomous or dangerous animals like lionfish, sea snakes, or flatfish, deterring would-be attackers. The environment itself shapes octopus behavior. Seasonal changes in prey abundance, water temperature, and current flow influence movement patterns, den selection, and reproductive timing. Octopuses may migrate short distances to optimize feeding opportunities or reproductive success. The selection of dens is critical, as a secure shelter provides both a safe haven from predators and a location to lay and protect eggs. Abandoned dens, however, may be reused by successive generations or other marine organisms, creating microhabitats that contribute to ecological diversity. Predation pressure remains a constant force. Sharks, moray eels, larger fish, dolphins, and seabirds actively hunt octopuses, while specialized invertebrate predators, such as certain crabs and parasitic worms, exploit their vulnerability. In response, octopuses have evolved a sophisticated suite of escape tactics. Rapid color shifts, sudden jet-propelled retreats, arm autotomy, and ink expulsion all serve as defensive measures. The release of ink, a complex mixture of melanin, mucus, and chemicals, creates a visual and chemical smokescreen that confuses predators, allowing the octopus to escape and relocate. Reproduction introduces another layer of complexity. Once sexually mature, males seek females, often navigating a perilous environment. Courtship involves color changes, arm posturing, and careful vibrations to signal intent while avoiding cannibalistic reactions. After mating, females focus on egg care, dedicating energy to guarding, cleaning, and aerating eggs for weeks or months. During this period, females may forego feeding entirely, exemplifying an extreme reproductive investment. Hatchlings emerge fully equipped for survival, continuing the evolutionary cycle. Ecologically, octopuses shape their habitats in subtle but significant ways. Their predation regulates populations of crustaceans, mollusks, and fish, preventing overpopulation and maintaining balance. The physical modification of their environment, through den construction, foraging activity, and the movement of objects, contributes to habitat complexity, offering shelter and feeding opportunities for other species. In effect, octopuses act as ecosystem engineers, influencing both the biological and structural dynamics of their surroundings. Humans have long been fascinated by octopuses. From ancient myths and folklore depicting them as sea monsters or guardians of treasure to modern scientific inquiry exploring their intelligence, the octopus represents a bridge between curiosity, culture, and empirical study. Research on octopus cognition informs fields as diverse as neuroscience, robotics, and materials science. Their soft, flexible bodies inspire designs for soft robotics capable of delicate manipulation, while the decentralized nervous system provides insights into distributed intelligence and adaptive behavior. Despite their resilience, octopuses face mounting challenges from human activity. Climate change, ocean acidification, overfishing, and pollution threaten both prey availability and habitat integrity. Shifts in ocean temperature can disrupt reproductive cycles and developmental rates, while chemical contaminants interfere with sensory perception and behavior. Conservation efforts aimed at protecting diverse marine environments are essential to ensure the survival of these extraordinary creatures, whose ecological and scientific significance continues to grow. Through all these pressures and adaptations, octopuses exemplify a remarkable balance of intelligence, dexterity, and resilience. Every movement, every color change, and every interaction with their environment is a testament to the evolutionary innovation that has enabled them to thrive for millions of years. From the shallow reefs teeming with light to the dim, abyssal depths where few other predators roam, octopuses continue to explore, manipulate, and survive in a world defined by constant change. Their story is one of quiet ingenuity and extraordinary adaptation, a narrative that continues to unfold beneath the ocean's surface, largely hidden from human eyes yet integral to the health and complexity of marine ecosystems. As the ocean currents shift and tides pull across the seafloor, octopuses continue their silent, complex lives, embodying a rare combination of intelligence, adaptability, and ephemeral beauty. In the darkest depths, where light barely penetrates, or along vibrant coral reefs awash with color, these cephalopods leave an indelible mark on their environment. Every arm movement, each subtle change in skin texture and color, is part of a delicate interaction with the ecosystem, a survival strategy honed over millions of years. Octopuses are masters of improvisation. A sudden threat may prompt a split-second decision, jet away, blend into the surroundings, or use a nearby shell as a shield. Their ability to respond dynamically to changing conditions illustrates an extraordinary capacity for environmental assessment and rapid decision-making. Unlike many creatures bound by instinct alone, octopuses demonstrate flexible problem-solving that can appear almost strategic. Observations have shown octopuses opening jars, navigating mazes, or even remembering solutions over days and weeks, behaviors that indicate advanced learning and memory. Camouflage remains central to their survival, but it is not merely a defensive tool, it is a form of communication. Color shifts can signal readiness to mate, aggression, or submission, and patterns can deceive both prey and predators. The mimic octopus, for instance, can replicate the appearance and movement of venomous sea snakes, flatfish, and lionfish, effectively rewriting the rules of predator-prey interactions through visual trickery. This level of behavioral complexity highlights a mind that can process, evaluate, and respond to multiple layers of environmental information simultaneously. The structural ingenuity of octopuses extends to their dens. Often dug into the sand, nestled among rocks, or hidden within coral, these shelters provide protection, a place for egg-laying, and a base from which to hunt. Some octopuses go further, lining dens with shells, stones, or debris, creating fortified microhabitats that demonstrate foresight, planning, and a remarkable spatial intelligence. These dens may later be reused by other marine creatures, reflecting the broader ecological impact of octopus activity. Their interactions with humans, whether in research, aquariums, or popular culture, continue to inspire awe and study. Scientists probe octopus cognition, exploring how decentralized nervous systems support complex behavior. Engineers mimic their flexible limbs in robotics, and neuroscientists examine the interplay of distributed control and problem-solving. Each discovery reinforces the notion that intelligence is not confined to creatures with rigid skeletons, fur, or vertebrae. It can emerge in unexpected forms in response to environmental demands and evolutionary pressures. Yet, octopuses are not invulnerable. Climate change, ocean acidification, overfishing, and habitat destruction introduce unprecedented challenges. Changes in water temperature can alter reproductive cycles, growth rates, and prey availability. Pollution and chemical contaminants may interfere with sensory perception, compromising an octopus's ability to hunt or evade predators. Conservation of marine ecosystems is essential not just for the octopus, but for the countless species influenced by its predatory and ecological role. In spite of these threats, octopuses persist. Their reproductive strategies, intelligence, and behavioral flexibility equip them to navigate a world that is both beautiful and hazardous. Each life cycle, from hatching through the intricate navigation of juvenile challenges to adult mastery of hunting and camouflage, illustrates a delicate balance between vulnerability and ingenuity. As night descends on the reef, octopuses emerge once more, exploring hidden nooks, hunting for food, and interacting with the environment in ways both subtle and profound. Their soft, flowing bodies and intelligent actions create a mesmerizing dance that reflects the complexity and elegance of marine life. The octopus reminds us that survival is not only about strength or speed, but also about creativity, adaptability, and the ability to perceive and respond to the nuances of a constantly changing world. Standing witness to an octopus at work, one cannot help but feel a sense of wonder at evolution's capacity for innovation. Every ink cloud expelled, each intricate web of color and texture, each deliberate movement of an arm is a testament to life's persistence and ingenuity. The octopus is more than a predator, it is a problem solver, an engineer, a master of disguise, and a silent participant in the balance of the ocean. In the end, the story of the octopus is a story of survival reimagined. It is the tale of a creature that transcends traditional notions of intelligence, adapts continuously to the shifting currents of its environment, and inspires curiosity and reverence in all who study or encounter it. Across reefs, seagrass meadows, and abyssal plains, the octopus spins its life quietly, creatively, and with a profound elegance, a living embodiment of evolution's ingenuity, a genius of the deep oceans.